Hello everyone, welcome to Disamtex's latest video about another group of additives for the paint industry, which is the anti-foaming agent group. Disamtex is an additive manufacturer based in Brazil, if you don't know it yet. And our 30-year-long history made us specialized in chemical solutions for the paint companies. So if you're interested to know more about us and our portfolio, check the description box below. Okay, so let's move on to the anti-foaming agents. First of all, I question you, what's the difference between an antifoamer and a defoamer? And the answer is antifoam agents are used for preventing foam from forming in the paint, while defoamers help eliminate existing air bubbles by allowing the trapped air to escape. So that's a technical differentiation. Although these two functions are often confused, they usually complement each other and are often combined in a single product designed to serve both purposes. Foam originates when air is incorporated into a liquid containing surfactants, which stabilize gas bubbles. These surface active molecules reduce surface tension and form a resistant film around the air bubbles, like you see on that image. So as a result, the bubbles don't collapse very easily, and a stable foam structure is formed. In coatings and industrial systems, excessive foam can cause defects, of course, such as craters, poor leveling, reduced mechanical properties, and so on. So a defoamer or an anti-foaming agent is therefore necessary to destabilize the bubble film, promote air release, and restore process and film quality. In order to answer, is foam a problem? I tell you, yes, foam can create serious application problems in coatings and paints. It reduces gloss and transparency, affecting the final visual appearance. Surface imperfections may appear, compromising smoothness and uniformity. Foam can also weaken the protective performance of the film, and additionally it causes production and packaging inefficiencies during processing. Foam in paints is often generated by mechanical stirring and mixing, and air can be released during pigment dispersion and wetting processes. So surfactants and other active ingredients may stabilize bubbles in the formulation, and application tools such as rollers and brushes can introduce additional air. So fast drying may trap bubbles inside the film as well, and that leading to blistering defects. In summary, antifoamers and defoamers are used to control and eliminate foam. Their function is to destabilize bubbles by reducing surface tension. They break the stability of micelles that keep foam structures intact, and proper compatibility ensures efficient foam control without surface defects. So you have an optimized balance there that will prevent craters, pinholes, fisheye imperfections, and so forth. What are the criteria for selecting an antifoam additive in paint formulations? And I give you 3 headings. Chemistry nature is critical, as mineral oils, silicones, polymerics, fluorocarbons behave differently in coatings, so pay attention to that. Also, a second thing is the process performance that will cover defoaming efficiency during manufacturing and ease of incorporation. And thirdly, application performance focuses on how well the additive suppresses foam on the dry film. Residual effectiveness over time ensures long-lasting defoaming during storage and application. So this sort of chart compares different defoamer chemistries: mineral oil, silicone, polymeric, polyurea. And each technology offers a different balance between competitiveness, foam breaking capacity, gloss retention, and crater control. So selecting the right chemistry is essential to eliminate foam without compromising surface quality. So that's the point here. Disamtex provides versatile anti-foam technologies to meet diverse formulation needs. So our portfolio ensures optimal defoaming performance combined with excellent coating aesthetics. So that's our goal. This is an important graph to visualize how effective a defoamer is when tested. So how do we test defoamers? Like this, because it shows the time of foam removal, how many cycles you need to actually get the foam removed. So in other words, how long it takes for the bubbles to disappear. So most defoamers will have a similar performance in the beginning of this test, but in the long term, effectiveness drops sharply after many cycles of shaking the sample, and depending on what the customer needs, this may be very necessary to understand. So let's see in practice the application and the importance of using an anti-foam agent. So I'll leave the conclusions to you. And first, you see a video without adding the additive, and then later with 0.4% of an anti-foam only. So I'll play it right now. You see all the bubbles remain there. They are stabilized. They cannot be removed, or they take too long to disappear. Yeah, so the film will dry and you will see blisters. Okay. and now with 0.4% of antifoamer. So you see that the application images clearly show the difference between coatings with and without antifoamer. In terms of killing the bubbles, the second case was much more consistent. And without antifoamer, excessive foam and surface defects are visible, affecting gloss and uniformity. And with the addition of Disamtex antifoam at a low dosage, the surface becomes smooth and defect-free. So effective foam control improves film appearance, application properties, and final coating performance. We can say Disamtex antifoam solutions guarantee cleaner finishes, higher quality results in paint formulations, and we are happy to say that. Now, this table presents the portfolio of water-based antifoam additives offered by Disamtex. It compares products by chemistry, mineral oil, silicone or blends, active content, dosage range, appearance, and end use. So the products are designed for a variety of applications, such as architectural paints, resin polymerization, construction, milling, flexography. Highlighted items indicate recommended or versatile options for common formulations. And overall, the chart helps formulators quickly match product chemistry to application needs they have. And this image shows the solvent-based antifoamer line from Disamtex, focusing on coatings that use organic solvents. Products are compared by chemistry type, silicone-based or polymeric, and recommended dosage. This whole matrix indicates performance across alkyds, pure alkyd, pure acrylic, universal pigment pastes, and epoxy systems. So the filled blue circles show strong suitability, while white partial circles show limited indication. And highlighted products represent key solutions aligned with market references like BYK Additives. So I believe that's all from me. I thank you very much for your wonderful attention and patience, and I hope we can remain in contact, and feel free to get in touch. So thank you very much again, and bye-bye.